Yes. So today we are going to see Maclaurin's expansion. What are the uses of it, and how do we solve different type of examples using Maclaurin's series? That's what we are going to see. Okay. So let me first revise how do we obtain Maclaurin series from Taylor series, and then we'll see how do we use it to solve different type of examples. So the first thing was in Taylor series expansion, which was f of a plus h. F of a plus h is equal to f of a plus h, f dash of a plus h square by factorial, f double dash a and so on. This is your Taylor series expansion. In this, what do? We put a is equal to 0 and h is equal to x. We put a is equal to 0 and h is equal to x. A is equal to 0 and h is equal to x to get the Maclaurin series expansion. So what it will become, just see now, this will become f of a 0, h is x. So it will become f of x is equal to f of 0 plus x, f dash of 0 plus x square by 2 factorial, f double dash of 0, f of x is equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. So this is your Maclaurin series expansion. Is that clear to everyone? From Taylor series, we get Maclaurin series, which is the special case by substituting a is equal to 0 and h is equal to x. So this is said to be expansion of the function about 0. The expansion of function about 0 is f of 0 plus x, f dash of 0 and so on. Expansion of the function about a means f of x is equal to f of a plus x minus a, f dash of a plus x minus a square by 2 factorial, f double dash of a and so on. That we did yesterday. So we'll see now how do we use this Maclaurin series to obtain various standard expansions that we have used till now. E raised to x expansion, you have used e raised to minus x, 1 plus 1 upon 1 plus x, 1 upon 1 minus x, log of 1 plus x, sine x, cos x, tan x. All those standard expansion that we have used or we know are been obtained with the help of Maclaurin series. Okay, so we'll see how do we get few of them, and then we will write down all of them to use so that we can use them to solve the other examples. Is it okay? Fine.
Yes, ma'am.
So write down the heading as standard expansions using Maclaurin series. Standard expansion using Maclaurin series. Standard expansions using Maclaurin series. Write down the first question. Expand e raised to x. Expand e raised to x in ascending powers. Expand e raised to x in ascending powers of x. In ascending powers of x. Expand e raised to x in ascending powers of x using Maclaurin series. Obviously, you'll be using your Maclaurin series. Okay. So for that, what's the Maclaurin series? Yeah.
Ma'am, repeat the question.
Expand e raised to x. Expand e raised to x in ascending powers of x. In ascending powers of x using Maclaurin series.
Hello, ma'am. You are not audible.
Others, can you hear me?
Yes, ma'am.
Gayatri, please check your connection once again. Expand f of x is equal to e raised to x in ascending powers of x. In ascending powers of x using Maclaurin series. Using Maclaurin series. Okay. So how you are going to do that? You know the function is e raised to x. You know that the function is e raised to x. So you have to use Maclaurin series means you have to use f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. Okay. So write down all the derivatives. How many derivatives are possible of e raised to x?
Infinite.
Infinitely many. So you will get an infinite series expansion. You will get an infinite series expansion of the function e raised to x. So let us do that. Okay. First is f of x is equal to e raised to x. F dash of x again e raised to x. F double dash of x is also e raised to x. F triple dash of x is also e raised to x and so on. None of the derivative is vanishing. So all the derivatives are existing. So find what is f of 0, what is f dash of 0, f double dash of 0 and so on. All of them are same. All of them are same. What is f of 0? Put in place of x. Yeah. Put in place of x 0. So it is e raised to 0, which is 1. F dash of 0 is also e raised to x. So it is e raised to 0, that is again 1. This is also 1. So all the derivatives are turning out to be 1, and therefore your expansion for e raised to x using Maclaurin series. What's a Maclaurin series? F of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. So substitute the values of f of 0, f dash of 0 and you will get the answer. So f of 0 is 1 plus x into f dash of 0 is also 1 plus x square factorial into f double dash of 0, that is also 1 and so on. So your expansion is e raised to x is equal to 1 plus x square factorial plus x cube by 3 factorial plus dot dot dot. That's your expansion of e raised to x. Clear? Everyone?
Yes.
Yes, ma'am.
Okay. Quickly, you find out what is the expansion of log of 1 plus x using the same Maclaurin series. This is your function f of x now. This is your function f of x. So you should know the derivatives of the function. Then you'll be able to write down what is the Maclaurin series expansion of log of 1 plus x. All these questions will be asked in your MCQ exam for 1 mark. Standard expansions they are called. Okay. So you know what is f of x? Is this. So find f dash of x. What is f dash of x? Derivative of log of 1 plus x. That is 1 over 1 plus x. Derivative of log of 1 plus x is 1 upon 1 plus x. And double dash of x is derivative of 1 upon 1 plus x one more time. So what is that? 1 upon function derivative is minus 1 upon function square. Minus 1 upon function square into derivative of the function. 1 derivative is 0 plus x derivative is 1. So it is 1. Okay. Continue this way and you will get the answer of all derivatives.
मैम x की जगह 0 पुट करना है ना?
Yes, you have to put in place of x 0 and then you get the answer. So f of 0 is nothing but log of 1 plus 0, that is log 1, which is 0. Log 1 is 0. Then f dash of 0 is 1 upon 1 plus 0, that is 1 upon 1, which is 1. Then f double dash of 0 is minus 1 upon 1 plus 0 the whole square, which is minus 1. Okay, please you find one more derivative because there's something different of this example. It's not just plus 1 or minus 1. It will be some other values also. So find one more derivative, f triple dash as well as f4 derivative. We are trying to find the standard expansion of log of 1 plus x using Maclaurin series.
2 upon 1 plus x raised to whole cube.
Correct. So just see what's the third derivative of the function. Okay. Third derivative of the function. Let me rewrite this in a proper form. This is minus 1 plus x raised to minus 2. Minus 1 plus x raised to minus 2. So what will be one more derivative? Minus 1 into minus 2, 1 plus x raised to minus 3. So that is 1 into 2 upon 1 plus x raised to 3. 1 plus x raised to 3. So that's why f triple dash at 0 will be nothing but, I'll write this 1 into 2 as 2 factorial, okay? Upon 1 plus 0 is 1, cube is 1. So triple dash at 0 is 2 factorial. What will be the fourth derivative? What is the fourth derivative? This 2 factorial will be as it is.
Minus 6 upon 1 plus x cube.
minus
Yeah.
3 factorial.
Correct. So please don't write minus 6 because it is in terms of factorial, so the terms will get cancelled and your answer will come quickly. So 2 factorial is minus 3 into 1 plus x raised to minus 4. So therefore, derivative at 0 will be minus 3 factorial. 1 plus 0 is 1, raised to minus 4 is 1. Okay. So now you substitute the expansion of, substitute this in the expansion of Maclaurins series. That is f of x. What is f of x? What's the function we started with? Log of 1 plus x. So log of 1 plus x is equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 plus x cube by 3 factorial f triple dash of 0. So this is your expansion. Is it okay? Now substitute the value of f of 0, f dash of 0, double dash, triple dash, and so on. And that will be your final answer. Is this clear? So what is f of 0? It is 0.
मैम फोर्थ डेरिवेटिव माइनस
X
6
into
आएगा
f
ना?
dash, that's 1. Minus 6 क्या है लेकिन 2 factorial into 3 is 3 factorial also. Now why I write that? Because you see in the formula 2 factorial, 3 factorial and so on, they will get cancelled. That's why I'm writing it in that particular form. Okay. So x into 1, then plus x square by 2 factorial into double dash of 0. That is minus 1. Okay. Plus x cube by 3 factorial into third derivative at 0. What is that? 2 factorial. Plus x raised to 4 by 4 factorial into minus 3 factorial. And so on. Correct terms. I hope you can see this. Yeah. So finally, should I rub this now? You have written it, the first part?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. Therefore, your expansion of log of 1 plus x will become x. 2 factorial is 2 minus x square by 2 plus 3 factorial 2 factorial. What's the relation? 3 factorial is 3 into 2 factorial. So 2 factorial will get cancelled. X cube by 3. Is this okay?
Yes, ma'am.
Next term will be minus 3 factorial
X to
4
power 4 by
x raised to 4 by 4 and so on. So alternate plus minus sign and x upon 1 x square by 2 x cube by 3 x raised to 4 by 4 and so on. That's your expansion. Log of 1 plus x. All this we have derived with the help of Maclaurins series. That's why they are important. They are used in solving so many examples. Okay? Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
This way we can obtain all the formulas. Let's write down those formulas. Because they will be used to solve another examples which are there in your syllabus. Okay? So should I rub this part and start getting the formulas? Everybody can see what I'm writing on the board clearly, na? It's not blurred.
Yes, ma'am.
Yes, ma'am.
Writing, can you hear me now clearly? Gayatri, are you there? So first expansion of e raised to x. First expansion is of e raised to x. Which is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. This is your standard expansion of e raised to x.
मैम स्क्रीन एडजस्ट करो ना.
Which is the standard expansion of e raised to x. Okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next is, this is first one. E raised to minus x. Can anybody tell me what is the expansion of e raised to minus x?
1 minus
Alternate
x.
minus.
Alternate plus
Well,
minus.
minus x now. So odd terms will give you negative, even terms will remain same. So that's why 1 minus x plus x square by 2 factorial minus x cube by 3 factorial and so on. This is your standard expansion for e raised to minus x. Clear? Third is Sine X. Third is Sine X. So again, how will you remember? Because these are going to be asked directly for your MCQ. What's the expansion? Sine X is an odd function, so it will have all odd powers. And with alternate plus minus sign, because the derivatives are alternately plus minus. That's why it is all odd powers x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on. Sine X is odd function, alternate plus minus sign, powers are all odd divided by those factorial. Clear?
Yes, ma'am.
On the same basis, who will tell me what the expansion for cos x then? What type of function is cos x? Even function, right? So which powers it will have? Even powers. So what are even powers? X to the power 0, which is constant, 1, minus x square by 2 factorial plus x raised to 4 by 4 factorial. I am simultaneously telling you how to remember also. This is your cos x. Then 10x. 10x is also a function, but the coefficients are not very straightforward. So you will have to go for the formula. If you are not able to remember, then you have to find the derivatives and get the value. But just see whether you can remember it. It is nothing but 10x is odd. So x and all sides are even. Okay? X plus x cube by 3 plus 2 by 15 x raised to 5 plus 17 by 315 x raised to 7 and so on. Coefficients are not simple. If you are able to, this is easy to remember. X cube by 3. 2 by 15 is what if you remember properly, then no other expansion has this coefficient. That's why that will be your answer. Only thing, 10x all are possible. That should be properly remembered. This also can be proved with the help of Maclaurins series. Okay. And sixth is, just now we have proved log of 1 plus x. Log of 1 plus x. So what is log of 1 plus x expansion?
X minus x square upon 2 plus x raised to 3 upon 3.
Just now we saw it. It is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus so on. That's your log of 1 plus x expansion. Who will tell me what is log of 1 minus x expansion?
All negative.
Bolo. Varad, yes, you're right. Say it once again.
I'm all negative with all negative signs.
Correct. Because when you put x is equal to minus x, all terms will become negative. Even terms are already negative. So entire series will be minus. So it is minus x square by 2 minus x cube by 3 minus x raised to 4 by 4 and so on. Okay. Then eighth one is 1 over 1 plus x. Eighth one is 1 over 1 plus x. Who will tell me what will be the answer? The way that you can get the answer is written on the board only. Expansion which I have already written, you can get the answer from there. The formulas that we have written just now, 7 formulas from there. Who will tell? I want 1 upon 1 plus x. Yes, Shivani?
Ma'am,
Yeah. Shraddha, yes, you can
ma'am,
tell.
x square upon 2 minus s cube upon 6.
You're telling the final answer.
Yes.
X square upon
2.
I don't think so. It will start
Ma'am,
with constant.
derivative of
It will start with 1.
ma'am, derivative of log 1 plus x.
Vivek,
That formula.
Aditya, what you're saying? Deshmukh?
Ma'am, if we differentiate expansion of log 1 plus x.
Absolutely right. Correct. Very good.
Yes,
Vivek.
derivation.
Yes. This log of 1 plus x is there, na? If you differentiate this on left hand side, you get 1 upon 1 plus x, isn't it?
Yes, ma'am.
And then differentiate this term by term, you'll get the answer. Fine? So write down that. Differentiating 6. Differentiating 6 with respect to x. Log of 1 upon 1 plus x. Log of 1 plus x, the derivative is 1 upon 1 plus x, which is equal to derivative of x is 1 minus 2x by 2 plus 3x square by 3 minus 4x cubed by 4 and so on. So your 1 over 1 plus x, 1 over 1 plus x will become 1 minus x plus x squared minus x cubed and so on. Okay. Alternate plus minus sign with all powers of x, starting with 0. X to the power 0 is 1. So what will be the ninth one? 1 over 1 minus x.
Differentiating log of 1 minus x.
Yes, differentiating log of 1 over 1 log of 1 minus x, you get the answer. What the answer?
1 plus x
Minus 1 minus x.
All
Minus
negative.
x. Yes.
Please see once again. Are all negative. Here you see that the derivatives will become negative. But what about the left hand side derivative? This also is negative. Log of 1 minus x derivative is 1
Minus-
over 1 minus x into minus 1. So all that minus sign will get cancelled and you'll get the answer to be all positive. Yes or no?
Yes, ma'am.
Or if you don't go by that way, what is the other thing? Replace x by minus x in this 8th formula. Replace x by minus x in 8th formula. All terms which were negative, they become negative of negative, so positive. Therefore, directly 1 plus x square plus x cube plus dot. That's your expansion. And then finally take this binomial expansion. 1 plus x raised to n. This we have already told you, or you can also check by Maclaurins. It turns out to be 1 plus
And
nx
please exit
plus
camera.
n. Pardon? Replace x by minus x in this formula. It will become minus of minus x, so plus x. Minus x squared is plus x squared only. Minus x cube is minus x. The whole cube is minus x cube. So minus into minus will become plus. And therefore you get the answer to be plus. So all terms will become plus. 1 plus x square plus x cube plus dot dot dot. And binomial expansion is 1 plus nx plus n into n minus 1 by 2 factorial x square plus dot dot. That's your standard 10 standard expansions which we are going to use to solve the exam. And all of them can be derived with the help of Maclaurins series. Okay. So now we'll see some examples which are the application of the standard formulas. Okay. So you take down the heading as examples using standard expansions. Example using standard expansions. Examples using standard expansion. So the first question is expand square root of 1 plus sine x, square root of 1 plus sine x in ascending powers of x. Expand square root of 1 plus sine x in ascending powers of x up to x raised to 6. Up to x raised to 6. So you will go to use this standard expansions to find it. So first of all, which standard expansion can you see clearly? Sine x you can see, na? So what's the formula for sine x? All odd powers, alternate plus minus sign and 3 factorial. But then that power is raised to half. So if you try to use binomial also, it will become complicated. Here half and then so on. Getting it? Because sine x is itself an infinite series. So is there any other way to convert this 1 plus sine x in terms of square power so that square root and square will go and your expansion will become simple? Correct. You are going to make use of which formula? Trigonometric formulas you are going to make use. So sine x, what's the formula for sine 2 theta? What's the formula for sine 2 theta? 2 sine theta
into cos theta.
into cos theta. Just see now which formulas I am using. Then 1 also can be written as cos square theta plus sin square theta is equal to 1. Correct? Na? So that if I try to use this 2 for 1 plus sin x, I can get it converted in square power. But here it is not sin 2x. Is it sin 2x? No, it is sin x.
डायरेक्ट फॉर्मूला है ना sin x plus cos x.
हाँ बोलो कौन सा?
मैम sin x plus cos x the whole square. बट अभी स्क्वायर रूट है इसलिए sin x plus cos x.
I didn't get it. Sin x plus cos x का?
अंडर रूट 1 plus sin x का डायरेक्ट फॉर्मूला है.
हाँ, so what is that?
sin x plus
This
cos x.
this one only, na? Yes, this one only. That I am trying to tell how you get it. Correct, you are. It is sin x by 2 plus cos x by 2 the whole square, and then that square and root will go. That's why I am doing it. Okay.
Yes, ma'am.
Yeah. So sin x is nothing but 2 sin x by 2 cos x by 2. Is it okay? This formula I have used here. Yeah, here it was 2 theta. So I got theta and theta. Now it's just x, so I get x by 2 x by 2. Half I get. Okay, and that's why I can use sin square theta plus sin square theta. I have to use sin square x by 2 plus cos x by 2 is equal to 1. So that it will become complete bracket square. Okay, so that's why this will become now. Just see, I'm using this one. Sin square x by 2 plus cos square x by 2 plus 2 times sin x by 2 cos x square. Is it okay? Clear? And then root of 1 plus sine x is equal to square root of a square plus b square plus 2ab. A square plus b square plus 2ab is a plus b the whole square. Is it okay? And that is nothing but square root x of sin x by 2 plus cos of x by 2. Now you know the standard expansion of sin theta and cos theta. Use those and you get the answer expansion. Is it okay? So let me write down. Sin theta expansion is theta minus theta cubed by 3 factorial plus theta raised to 5 by 5 factorial and so on. So that's why sin of x by 2. What will be sin of x by 2? X by 2 minus x by 2 cube divided by 3 factorial plus x by 2 raised to 5 by 5 factorial. Is it okay? Similarly, you write down the expansion for cos. That will give you the answer. That will give you the final answer. Is it okay? So substitute and see, please. Similarly, cos x by 2 will be on even powers, that is 1 minus x by 2 square by 2 factorial plus x by 2 raised to 4 by 4 factorial minus x by 2 raised to 6 by 6 factorial. If it comes for the theory exam, all entire will come for 6 marks or 5 marks. And if it comes for MCQ, they'll give you this step and they'll ask you what is the final answer. They'll give you sin x by 2 plus cos x by 2 infinite series expansion or Maclaurin series expansion. For that is substitute the two formulas and get the answer. So do it please and tell me what's the final answer. This is 2 from 1 and 2, from 1 and 2. Expansion of sin x by 2 and cos x by 2. Here 1 and 2. From 1 and 2, we will get, just see, first write the constant term, 1. There is no constant term in the sin x by 2. Then power x. Which term has power x? Sin x. So it is plus x by 2. Then x square term. So it is minus x square by 2 square is 4 into 2 is 8. Plus or minus x cube term. Yeah. There is x cube term which is with minus sign. So it is minus x cube upon 2 cube. 8. 8 into 6. 48. 8 into 6 is 48. Plus or minus x raised to 4. So plus x raised to 4. 2 raised to 4, 16. 16 into 4 factorial is 24. Do that and tell me what the answer.
380.
16. 3.
380.
84. Plus x raised to 5 upon 32 into 2 raised to 5 is 32 into 5 factorial is 120. And minus x raised to 6 upon 2 raised to 6 into 6 factorial. And so on. So the final answer is 1 plus x by 2 minus x square by 8 minus x cube by 48 plus x raised to 4 by 384 plus x raised to 5 by how much is that? 3840 and minus x raised to 6 by 2 raised to 6 into 6 factorial.
46080.
46080. The final answer. So these questions are there. I've shared the MCQ set. Please go through that and solve those questions. Okay. And tutorial also have shared. Please go through that. We will solve in the tutorial session some of the examples, some of the questions you have to solve.
मैम वो ट्यूटोरियल का एक क्वेश्चन लो ना, log of 1 plus e raised to x.
Log of
1 plus e raised to x.
okay, fine. We will do that. So that the entire class only will get the answer. Please complete this quickly so that we can start with that. Have you tried? But first, tutorials are for you all to try, and then if you don't get it, I will.
सॉल्यूशन पे
मैच नहीं हो रहा है. हाँ, सॉल्यूशन से मैच नहीं हो रहा है.
हाँ मैम, मैच नहीं हो रहा है. वो 2 क्वेश्चन तो हो गए, वो थर्ड वाला नहीं आ रहा था.
Okay. So let the others also try, and your batch is C3, na? I think so. It's Arjun.
Yes ma'am.
Okay. So I'll solve it in the tutorial class. Is that okay? Or should we do it right now?
Okay.
Others also want it? Because there are many more examples which we have to solve. That's why. Should we go ahead? That question I'll solve in tutorial class, okay? Now let me go for the next question, MCQ questions. That also are important, so let me solve few of them. Because the final exam will be online only. So let me solve. And in today's tutorial class also, if you have some doubts of questions that I have shared on your Google Classroom for MCQ, you can ask those also, okay? Take down the question which I want you all to solve right now. We will solve it together. Expansion of log of 1 plus x raised to 1 by x. Log of 1 plus x raised to 1 by x. I'll write it down first, okay? Expansion of log of 1 plus x raised to 1 by x in ascending powers of x is. In ascending powers of x is. This is almost that type only, okay? Let's see how do you get it. Yes. So what is this actually equal to? This will come now 1 by x log of 1 plus x. Now you have to use the expansion of log of 1 plus x. So what's the expansion of log of 1 plus x? X minus x squared by 2 plus x cubed by 3 minus x raised to 4 by 4 and so on divided by. Let's see, this is 2 marks question, so simple it is. Just divide by x and that will be your answer. So 1 minus x by 2 plus x squared by 3 minus x cubed by 4. So, okay? This is one example of x. Let me have another. Expansion of cos square x in ascending powers of x. Expansion of cos square x in ascending powers of x. Try this one, some of you all.
Ma'am, we can use Maclaurin's theory in this.
So you're going to write f of x is cos square. And then you're going to find the derivatives you're saying.
Yes, ma'am.
You can, but it will become lengthy because if it is a question of
Ma'am, trigonometric formula that 1 plus cos 2x by 2.
yes, I told you in the first tutorial session. Whenever you have cos square or sine square, easier it will be to convert it to degree 1 term. What is cos square formula? You can go for
1 plus cos 2 theta by 2.
correct. So it is 1 plus cos of theta is 2x divided by 2. And the answer which is there in the options also will be on this step. That will give you the hint actually. Okay. So this will become 1 by 2 plus 1 by 2 into cos 2x. And you know what is the expansion of cos 2x? Substitute, that's your answer. So it will become 1 by 2 plus 1 by 2. Cos 2x is one even function and your theta is now 2x. So 1 minus 2x square by factorial plus 2x raised to 4 by 4 factorial. That's your answer. This will be present in the option. So how many lines to clarify? Is it okay? If you go for f of x is cos square and for Maclaurin series, it will definitely increase the number of steps and then your time will go. So try to be smart enough to understand which is the method that will be followed. So let us go to the next type of question first, which will give you the expansion of tan inverse sine inverse. Okay, so we'll go to the next type of question, which will give you the expansion of tan inverse sine inverse, and that is called as method of differentiation and integration. Write down the heading. Expansion using differentiation and integration. Expansion using differentiation and integration. Okay, so the question is prove that tan inverse of x is equal to x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 and so on. This is the expansion that you have to prove. Prove that tan inverse of x is equal to x minus x cubed by x minus x cubed by 3 plus x raised to 5 by 5. We have not written this in the standard formula. This we have not written in the standard formula. So if I try to use Maclaurin series for this, it will going to become a bit lengthy. Just see, it is power 7. So how many derivatives you have to find?
7.
7 the derivative.
7.
First derivative of tan inverse is 1 upon 1 plus x square. So second derivative will be minus 1 function square into derivative of the function, which will become very, very complicated. So I cannot use directly Maclaurin series for this function. So there will be some other method. You have to use standard formulas, but there will be some other method. So what's that? That is called as method of differentiation and integration. Is it okay? So let us see how. Your function f of x, y is equal to f of x is tan inverse x. This is your function. Okay. So what I will do? I'll first differentiate. I will first differentiate. So what I will get? Differentiating dy by dx is what's the derivative of tan inverse? 1 upon 1 plus x. Is that clear, everyone?
Yes,
Yes or no? But I know some standard formula which gives me the answer of 1 over 1 plus z. Can you see this part? 1 over 1 plus z expansion. I have written it in terms of x there. I am writing here in terms of z. So what's the expansion of 1 over 1 plus x or 1 over 1 plus z? Let me write it here so that everyone can see. 1 over 1 plus z is 1 minus z plus
Plus z square minus z cube. Plus.
Is it okay? Everyone, this is the expansion. Be sure. In place of z, what I have now? X squared. So what it will become? 1 over 1 plus x squared will become 1 minus x squared plus x squared squared minus x squared cube and so on. So that it will become 1 minus x squared plus x raised to 4 minus x raised to 6 and so on. Is it okay? So this is nothing but 1 minus x squared plus x raised to 4 minus x raised to 6 and so on. Can you compare now this question and the answer? Dy by dx this. So now if I again integrate it, I will get the answer. Are you getting it? So that's why this method is called as method of differentiation and integration. So you have therefore dy by dx is equal to 1 minus x squared plus x raised to 4 minus x raised to 6 plus dot dot dot. And now integrate this to get the expression. Therefore, dy is equal to, just see, dy is equal to 1 minus x squared plus x raised to 4 minus x raised to 6 plus dot 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 into dx. Since I want to do integration, I am taking that left side. Integrating, and this is definite integration. Integrating with respect to x from 0 to x. Integrating both sides from 0 to x. Integration dy from 0 to x is equal to integration 1 minus x squared plus x raised to 4 minus x raised to 6 plus dot 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 dx from 0 to x. From 0 to x. So actually dy integration is y from 0 to x, which is what's the integration of 1x? What's the integration of x squared? X cubed by 3. What's the integration of x raised to 4? X raised to 5 by 5 minus x raised to 7 by 7 plus dot 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 from 0 to x. From 0 to x. And that's why y of x minus y of 0. Y of x minus y of 0 is equal to, lower limit will give you 0 only. It is x minus x cubed by 3 plus x raised to 5 by 5 and so on. What is y of x? Just see. Y of x is f of x is equal to tan inverse of x. What is y of 0? Tan inverse
0.
and but tan inverse of 0 is 0.
0.
That's why we get the answer. Tan inverse x is x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7. And that's our expected answer. Is it okay? This is method of differentiation and integration. Similarly, you can also get the expansion for sine inverse x, cos inverse x. We have written one formula. I told you, even if you don't write, it's okay. Sine inverse x plus cos inverse x is pi by 2. Correct? So if you get formula for sine inverse, formula for cos inverse will be pi by 2 minus sine inverse. So today's homework will be find the expansion of sine inverse x using this method. Homework is find the expansion of sine inverse x. Find the expansion of sine inverse x using method of differentiation and integration. Okay. Using that, using the same, Using the same cos inverse x will be, using the same cos inverse x will be sine inverse x minus pi by 2 minus sine inverse x. Cos inverse x will be equal to pi by 2 minus sine inverse of x. Pi by 2 minus sine inverse of x. Is it clear, everyone? Few examples of definition of this are left. Those we do tomorrow, and then we start with indeterminate form. Not tomorrow, we are okay. So let me
Ma'am,
take your
repeat the
attendance.
question.
If you have any doubt, you please ask in today's lecture.
Ma'am, can you repeat the question?
Yeah, just a second. I'll repeat it. Find the expansion of sine inverse of x. Find the